Question 14. David and Anna have these cards. 1, 2, 3, 5, 6 and 7. Part A. David uses 4 of the cards to make a pair of equivalent fractions. Now equivalent fractions are two fractions that have the same value. Write numbers in the boxes to show how David can do this. So we're looking for two fractions that mean the same thing. And one way to identify this is if you multiply the top number by something and you multiply the bottom number by that same value. We could try an experiment by putting a half to start off with using the numbers 1 and 2. If we chose to double both of those numbers, we would end up with a 2 at the top and 4 at the bottom. Now unfortunately that means we've doubled up with the number 2 card. So what happens if we multiply both of these values by 3? 1 times 3 is 3. 2 times 3 is 6. That makes correct use of the cards that we have. 3 and 6 are there, and it's made sure that they're both still equivalent. Part B. Anna has the same cards. She uses 4 of the cards to make a different pair of equivalent fractions. Write numbers in the boxes to show how Anna can do this. Now unfortunately we don't have a card with a number 4 on, otherwise we could have potentially used 2 quarters. So we have to look for another combination of numbers. We can no longer use a half, so we can try the next fraction, which could be 1 over 3. 1/3. So to find an equivalent fraction to a third, we can try doubling both of these numbers. 1 times 2 is 2. 3 times 2 is 6. Those cards exist, and both of these fractions are equivalent to each other because they're both been doubled. The numerator and the denominator have both been multiplied by the same value, which makes them equivalent.